Welcome to the 8th week of discussion session of the course Finite Element Method, course offered by NPTEL. The course instructor of this course is Professor Biswanath Banerjee and Professor Amit Shah, and myself, I am Asif Raza. I am your teaching assistant. I am a PhD scholar from Department of Civil Engineering, ISC Bangalore. So, as I said already, just stated that we can discuss questions relevant to assignment number 9. So I'll first start that thing. Okay, Jess, you want to add something? You can unmute yourself and say.
Okay, sir. Actually, I have written there week 8 and week 9. I was not ignoring week 8 actually.
Okay, okay,
To facilitate doing the assignment for this week, I was just asking if we could get a training on week 9 also. It would be useful.
okay. So one
Okay.
thing I can do is okay. So I started with the mindset that now I have to discuss week 9.
No, no
So
issues.
no,
No
no,
issues.
so no worries. I'll discuss some questions of week 9 and solutions of week 8 if that is fine.
Yeah, yeah.
Okay. If it is okay with everyone, actually.
Yeah, I was also waiting for that. Was just my opinion. So, week 9 will be more welcome to me. But since this is recorded and posted, there may be people waiting for week 8 also.
Okay, okay. So we'll do that one also. If not possible, we'll do in later sessions also, like in
Yes,
week
yes,
9, week 10, week 11. I'll mix it
yes,
then.
yes, sir. Thank you.
Okay. So we'll start with today's session with first question relevant to week 9 or assignment 9, I would say. So this is the question. I hope it's visible to all. So question is, suppose there is a body of thickness h and it is made up of an isotropic material. Now the governing differential equation for the body under no body force and inertia effect is given by this, where sigma u and n are stress, displacement and outward unit normal respectively. U bar is prescribed displacement and T bar is prescribed traction. V is volume of the body, gamma T and gamma U are the regions of traction and displacement boundary condition respectively. If lambda and mu are Lamèche constant, the weak form corresponding to 2D elasticity case is, and these are the four options given. So I don't know if you guys can directly answer it. So because there are a lot of constants involved and it's a big equation, so I'll just start solving. If anyone has suggestion or any doubt, you can please jump in. So as it's given, the body is made up of isotropic material. Now using Lamèche constant, we can write sigma xx as lambda plus 2 mu del u by del x plus lambda del v by del y, and sigma yy as lambda del u by del x plus lambda plus 2 mu del v by del y, and sigma xy as mu del u by del y plus del v by del x. Okay, this is for the isotropic body. How can we represent it? Now this is our governing equations, right? So we need to use this to form our weak form corresponding to 2D elasticity case. So uh, this can be resolved by, so we have delta dot sigma equal to 0, right, in the boundary condition. So uh, this is, if you say mm, so this is with regards to, like, there are two equations incorporated, del sigma xx by del x plus del sigma xy by del y equal to 0, del sigma xy del x plus del sigma y by del y equal to 0. So we multiply with w1, w2 weight function and integrate it throughout the domain. Okay, as we solve for convert strong form to weak form, so I am saying we multiply this plus this. Okay, now using integration by parts, we can do so w1 this one dx dy. Yes, this is it, and xy, this is in the domain dx dy. Right. Okay, and it is multiplied throughout because dx dy is there, right? So it's a volumetric integral. Okay, I made a mistake here. Dx dy, it's a volumetric integral. So volumetric integral on integration by parts or some using that, it will convert into an area integral. Okay, so this is with this part. Now regarding this part, it will be plus h del w2 by del x sigma xy del w2 by del y sigma yy dx dy, and these are all, if you observe, okay, something really, okay, I made a mess over here. This thing, I'm making a mess. Okay, so this is first statement. This equation multiplies with w1 integrated in this domain, and the second is v w2. Okay, I was making a mistake here. Plus del sigma yy del y dv equal to 0. This is second. So okay, so let's complete this, right? Equation 1, equation 2. So for 1, it will be something like this. So these are like the transference of the boundary integral. Now so this this is a volumetric integral, so when we write it, it will be directly dx dy omega h, because it's a 2D case, reduced 2D case. So dx dy omega times thickness h. Now it's a area integral. So first in the integration by parts is the transference of the differential to the weight function, that is being done. Now in the later part it comes the boundary terms, and that is minus h till the boundary terms. Then the blue one, uh, uh, it will be sigma xx nx plus sigma xy ny. This is okay, the s equal to 0. Here nx and ny are unit normal. Okay, to the curve outward. Okay, so this is it used for 1, and we have sigma xx already defined as this. I'll say this one as a b c. Okay, so from a, this equation can be simplified as h omega del omega w1 by del x. Sigma xx was lambda plus 2 mu del u by del x plus lambda del v by del y plus del w1 by del y. Sigma xy was mu del u by del y plus del v by del x, and this is throughout the domain dx dy minus h w control w1 sigma xx is lambda plus 2 mu del u by del x lambda del v by del y and x plus sigma xy is mu del u by del y plus del v by del x and times ny ds equal to 0. So this is the weak form for the first part of this equilibrium equation. Similarly, we can do the second. Okay, for 2. So for 2 we have this weight function, this is the equation. So using integration by parts, we can write as h in the domain of del w2 by del x sigma xy plus del w2 by del y sigma y. Okay, this is dx dy minus h line integral w2 w2, and this is sigma x y and x plus sigma y and y in the line control equal to 0, and from B and C, from A and B, A and C, and yeah, B and C. Yeah. So this can be simplified further as H omega del W2 by del X sigma xy is mu del U by del Y plus del V by del X plus del W2 uh, del Y sigma YY is uh, it was lambda del V, sorry, del U by del X plus lambda plus 2 mu del V by del Y, and this is in the domain dx dy minus H W2 sigma xy is again this lambda U del Y del V by del X in X plus lambda del U by del X plus lambda plus 2 mu del V by del Y ny ds equal to 0. Okay, so these are the weak form corresponding to our 2D elastic case. So let us see what will be the correct option regarding this. Let's see. So I don't think here it should be lambda plus mu, so it's better this one. Don't consider this one. Now this option B, lambda lambda plus 2 mu. This is good. This is good. Then this is also good. Minus W1 lambda plus 2 mu nx. This is fine, and this is also fine. And this one W2 mu. This is also good. This is also good. So this statement is also fine. So correct option would be option B. I hope nobody has doubt here. If anybody has doubt in any of the solution, like any part of the solution, you can ask now, or we can move on to the next question.
Could you please remember us the Green's theorem? I believe here is used. How how it is used here? Green theorem, or
Okay, so you're saying, so if we have P dx plus Q dy, if I remember it correctly, and P is a function of x and y, and Q is a function of x and y in the contour. So this can be transferred directly to the domain such that del q by del y minus del p, del p by del y, del q by del x minus del p by del y dx dy. Right? Is this the one you are talking about?
yeah,
Yeah. So this is indirectly using this thing itself, like
why are we how were we used here?
okay. Let's say, so let us take only one of the statement. So rather than taking everything, let's say this one. Okay. W1 multiplied with del sigma x y del x. Sigma x y del y. No. Okay, so directly I don't think we can use is a W is a
I asked because finite element method is using some special form of this theorem. And last time when I took this course, I also didn't understand this. This normal appear as you can see there. This normal is tricky there.
okay. Uh, if I solve this using the way if I using what to say um, solid mechanics course, like how do they solve this delta dot sigma equal to 0, right? And this is we are multiplying with some weight function, suppose w and delta dot sigma ds equal to 0. Now uh, delta dot sigma is can be
Sorry, are you sure that it is a? Are you sure that we should have a boundary integral here, curve integral? Your integral along the curve. When
I
you,
I'm not sure, like we have to
I believe
we can
we need to
use.
use volume integral.
No, actually I took it like see here H and this here. Yeah, you're
But
correct.
you dx
Yeah,
dy
you're correct.
dx dy
Here we
yes.
will use dv only.
Oh, oh yes.
If you are using all the three equations. Yeah, okay, it's fine. So if we see how this transference will occur, this is having this right. Uh, using this a Gauss divergence or um, mm, if I don't, it was Stokes theorem, I think. It was using Stokes theorem. This is this volumetric integral is transferred to area integral, if I remember it correctly.
Uh, it was done also in scalar form of equation, and
Right.
in the temperature problem we also use normals. And usually in math class, that considering this theorem, there is no normals in the scalar problem. So I wanted to ask you if you can put some thoughts here today or
Uh,
next session.
okay.
Where's no normal appears? This normal is not clear.
Okay. So let us take only one of this thing. Del sigma x x del x dx dy. Okay. So on integration by parts, if I take it like this, what we can have on integration by part del w1 by del x. No. So we'll have w1 integration of the second term. If I say this will be like this, right? But we are still having the integration has been done with respect to x only. We are still having dy, right? And I think here it's the way it is coming, it should be an x, I think. And the further transference of that integral will give me del w1 by del x sigma xx and dx dy. Okay, I'll dig this deep, and I'll let you know in the next session. Okay, so let's move on to the next question. Suppose strain, this is the second question. Suppose strain within a four-node quadrilateral element in finite element can be written as this. This is a strain vector, this is the strain displacement matrix, and this is the nodal displacement vector. The dimension of strain displacement matrix would be. So the question we are asking is regarding four-node quadrilateral element. So what do you think? What will be the answer? This is quite easy if you guys know the dimension of other uh, required stuff. So answers, please. Can anyone say? Uh, do notice that our element in consideration is four-node quadrilateral element. So what will be the dimension of strain displacement matrix? Okay, guys are taking time. I'll just ask step by step. What will be the dimension of this nodal displacement vector? What will be the displacement dimension? The element in consideration is four-node quadrilateral element.
The dimension is a column or 8 by 1.
Yes, this will be 8 by 1 because four nodes, four nodes, and each node 2 degree of freedom per node per se. So total 8. So the dimension of nodal displacement vector would be 8 by 1. Our strain displacement will have what? What will be the dimension? So at each point there are three things in consideration: epsilon xx, epsilon yy, and epsilon xy, right? So this is 3 by 1. So we have the equation strain in the element is equal to strain displacement. So we have the result as 3 by 1. We know this one as 8 by 1. So what would be the dimension here? So first thing will be here 3, and the second thing. So Rafael and Abraham both have said 3 by 8. Yeah, so correct answer is option D, 3 by 8. Okay, I think no one will have any doubt in this regard. Now let's move on to the third question. Suppose there is a constant strain triangle element for which nodes are given in blue dot as shown in the figure. Psi1, Psi2 and Psi3 are the shape functions for node 1, 2, 3 respectively, and the values of Psi I has already been provided, where alpha, beta and gamma values have been given in terms of x, y coordinates, where ijk are the permutation of natural order. What is the ratio of Psi1 and Psi2? So this is pretty straightforward, I would say. Yeah, this is everything has been already provided. So psi 1 would be what? 1 upon 2 AE alpha 1 plus beta 1 x plus gamma 1 y. Psi 2 would be 1 upon 2 AE alpha 2 plus beta 2 x plus gamma 2 y. Right. Similarly, psi 3 1 upon 2 AE alpha 3 plus beta 3x plus gamma 3y. Now we need psi 1 upon psi 2. So for that we need to know, okay, so psi 1 upon psi 2 is what? Alpha 1 plus beta 1x gamma 1y upon alpha 2 plus beta 2x plus gamma 2y. Correct? Now alpha 1 is alpha I values have been given as xjyk minus xkyj. xjyk minus xkyj. So alpha 1 would be equal to what? x2 y3 minus y3 uh, x3 y2, right? Yeah. ijk in the circular permutation 1 2 3, right? Then we have beta I as yj minus yk, yj minus yk, and gamma I as minus xj minus xk. Okay, so we have alpha 1 as x2 y3 minus x3 y2, alpha 2 as it will be x3 y1 minus 231 and x1 y3. Yeah, and beta 1 would be y2 minus y3, beta 2 would be y3 minus y1, gamma 1 would be minus of x2 minus x3, and gamma 2 would be minus x3 minus x1. Okay, now substitute everything in this equation, this ratio A. So psi 1 upon psi 2 would be equal to our alpha 1 is, okay, so before substituting we can just find the values x2 y3 and x3 y1. Let's write it a bit down. So let's see, node 1 has coordinate, so we'll write x1 equal to 1. Okay, node 1 having 1 comma 1, node 2 is 5 comma 1, and node 3 is 2 comma 4. So we have here correspondingly we'll have x2 is 5 times y3 is 4 minus x3 is 2 times 1, so this is 18. X3 is 2, y1 is 1, minus x1 is 1, and y3 is 4. So this is 2 1 is 2 minus 4, it's 2 minus 2. y2 minus y3, y2 is 2 minus 4 minus 2, then y3 is 4 minus 1, this is 3, this is minus of x2, x2 is 5 minus 2, right? Yeah, so this is 5 minus 2 minus 3, and this is minus of x3 is 2 minus x1 is 1, so this is equal to minus 1. Now for psi 1 psi 2 we had alpha 1 plus beta 1x plus gamma 1y, alpha 2 plus beta 2x plus gamma 2y. This is equal to 18, beta 1 is minus 2x, gamma 1 is minus 3y. Similarly, this is minus 2, beta 2 is 3 and gamma 2 is minus 1. So yeah, so this is it. 18 minus 2x minus 3y upon minus 2 plus 3x minus y. So option A would be the answer. Okay. Let's move on to the next question. Suppose a thin elastic square plate is compressed. This is in regards to question number 4 to 7. So, question is, suppose a thin elastic square plate is compressed with a uniformly varying load on its left edge. The body is discretized with two CST elements. The modulus of elasticity and Poisson's ratio are 60 GPa and 0.27 respectively. The thickness of the plate is 0.2 mm. Consider plane stress condition and answer the following question. In FEM, the element stiffness matrix is B transpose dB d sigma. What is the strain displacement matrix of element 1? Consider order of node numbering 1, 2, 3. So let's see if anyone wants to say like how will we proceed, or I'll just start then. Question number 4. Is question clear for everyone? Question number 4. The element in consideration for this question is CST element. I haven't finished this lecture yet. Oh. What about this? The question is clear. Okay. Uh, mm, okay, I'll just do this. At least question is clear and you can proceed. We need to know how is this in front. So first of all, we need to know what will be the dimension, as the element in consideration is a CST element. CST element has, it's a 3-node triangle. So each node 2 degrees of freedom, so total degrees of freedom is 6. So and at any point, kindly follow. Okay. So 6 degrees of freedom, and at any point we need 3 strain, epsilon xx, epsilon xy, epsilon yy. So the dimension of strain displacement matrix is 3 by 6. So that is inconsistent with all the options. Now we need to see 1, 2, 3. So element 1 has the configuration as this. One, two, three, with coordinates as 0, 0, 100, 0, and this as 100, 100. Now for a CST element, you can explore the strain displacement matrix. It's given by 1 upon 2 AE, then beta 1 0, beta 2 0. Should write it first. 1 upon 2 AE. AE is the area of the element. beta 1 0, beta 2 0, beta 3 0, then 0 comma 1 0 comma 2 0 comma 3, and this is gamma 1 beta 1 gamma 2 beta 2 gamma 3 beta 3. And what are these betas? As you just saw earlier, beta I is yj minus yk, and gamma I are minus xj minus xk. So with this, beta 1 would be equal to what? uh, y2 minus y3, and that is equal to y2 is 0 and y3 is 100. So this is minus 100, right? Let's find the values of other betas and gammas. So beta 2 would be equal to y3 minus y1, and that is 100. Beta 3 would be equal to y1 minus y2, and that is y1 minus y2, this is 0. Gamma 1 is equal to minus of x2 minus x3, this is equal to x2 is 100, x3 is also 100, so this would be 0. Gamma 2 minus x3 minus x1, and this is equal to x3 is 100 and x1 is 0, so this will be minus 100. And gamma 3 is minus of x1 minus x2, x1 is 0, x2 is 100, minus 100, and as a result it will be 100. Okay, now area of the element AE is what? This is a triangle, so half into base into height, and base is 100 and height is also 100. So area of the element is 250, so this would be 5000. Okay, so now substitute this into the element displacement matrix. This will be 1 upon 2 times 5000, and the other values minus 100 0 100 0 0 0. Gamma 1 is 0, this is 0 minus 100 0 100, and gamma 1 0, this is minus 100, this is minus 100 100, then this is 100, this is 0. Yeah, so options will be, did I made any mistake? No, it's fine. So this can be simplified further. So this is 2 5s are 10, so in the denominator it's 10 to the power 4, so everywhere 10 to the power 4 will give me this 0 0 0 0 0 0 minus 0.01 0 0.01 0 minus 0.01 minus 0.01 0.01 0.01 0. So saying this, correct answer would be minus 8. So answer would be option C. Okay. I would have solved question number 5, 6 also, but seeing the constant that we have to solve at the week 8 also, so I'll just jump into other part. So 5, 6. This was like question 4, 5, 6, 7. So let's solve question number 8. Let me check. Yeah. So question number 8 is this. Okay, so let's. Okay, this is saying please ask if other participants need week 8 or week 9. So rather than asking, I am just mixing, like I'll just solve some of the questions of week 9, and then I'll just again regroup back to question number, we assignment number 8 solutions. So I'll keep this short. Okay, so the question number 8. Suppose a 2D isotropic elastic body was in a temperature of 30 degrees Celsius. Suddenly, the temperature of the body reached to 600 degrees Celsius. The coefficient of thermal expansion, Young's modulus, and Poisson's ratio are this respectively. What are the longitudinal and shear component of thermal strain considering plane strain condition? Okay, I'll keep this question as the last question for assignment number, like in consideration to assignment 9. Then I'll jump into assignment 8 solution if that is fine with all. Seeing like Rafael has also not seen the lecture, so that is new. Okay, so I hope this question is clear. So
Yeah, I'm familiar with elasticity problem, of course. Even I just not convinced in every detail about finite element method of this
okay, okay,
problem.
no problem, no problem. Okay, so I think you have already read the lectures of week 9. So can you try this question?
Uh, this question is not about even finite element method, I believe.
Yeah, this is general.
So
So I don't think you guys should have any doubt, but still.
I can answer after this.
Okay, Jess, can you say something whether you will try? You can try or not. At least try. Jess, are you there?
Okay, just don't want to answer. There's
Okay,
no. I am sure that there's no shear strain at all. The shear is not considering in thermal expansion.
oh,
You get
nice.
that? So, and we just need to multiply all these
Okay,
thermal
so
coefficients, temperature, and I believe Poisson modulus is given here to find a Young mod. Sorry, Poisson coefficient.
no.
Tricky question. Okay, we just need to
Okay, Rafael. Uh,
just multiply this coefficient by Young modulus
I think
by
you,
the
you have got it, but I will still ask. Just he said reading question and understanding takes time for me, so I'll ask her. As you have already said, the that thermal shear component would be 0, so shear strain is 0. Seeing that answer, option C would be the best answer. But let's ask just. How will we get this answer? If she has any idea. If Okay, this is saying, please spare me. Okay, Rafael, continue. Rafael.
Okay. I believe a formula like alpha multiplied by delta t,
Okay, so
delta
we
x6.
need to find this, right?
Right. Okay. Delta x6 is equal to alpha delta t.
Yeah.
You can fill alpha delta t. Delta yy is equal to no. Delta yy is equal to, we need to use we need to use. Okay, I agree with you. I just wanted to say that it might be the case of Poisson effect of delta y, but
Yeah,
it's
so
no. I remember that there is no the case for thermal expansion.
no.
Okay.
It would be there. See, uh, you should remember that Poisson effect comes into consideration when we are constraining into one direction, and we induce thermal stress in the other direction. Poisson effect do come into play, and it's different case if it is plane stress or plane strain. So don't disregard the effect of Poisson's effect. So Poisson's effect will come into play. I wrote this equation. This is incomplete. I was going to ask this. So this is plane strain condition. So plane strain condition. So we'll just need to multiply it 1 plus nu. It looks like gamma here. Nu.
Look, by the way, you said interesting thing. Why we need to have a why it is different in plane stress and plane strain?
Okay.
I forgot that.
Okay. So uh, just simple thing. How do we write this? Uh, 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 uh. In engineering terms. Okay, how do you write this? Sigma xx upon E minus nu sigma xy, sorry, sigma yy upon E minus nu sigma zz upon E. Epsilon yy as sigma yy upon E minus nu sigma xx upon E minus nu sigma zz upon E in epsilon xy. Okay, now this is like in the general case, right? So if we simplify it further, sigma xx can be written in terms of epsilon xx, epsilon yy, and epsilon zz. Okay, now for plane stress and plane strain condition, this dependency will change, right? For plane strain, this epsilon zz is directly 0, right? So we have only in terms of epsilon xx and epsilon yy. And regards to plane stress, we have epsilon zz is equal to minus nu, because uh, 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 because somewhere I made a mistake of what. Epsilon zz is equal to 0, that will give me sigma zz is equal to nu times sigma xx plus sigma yy, right? Yeah, okay, yes, so I am going correct. And in plane stress, sigma zz is 0, so with that we have an additional equation epsilon zz in terms of epsilon xx and epsilon yy. It's a function of epsilon xx and epsilon yy. Again, it gets simplified, and this dependency of this coefficients will be different. So consequently, epsilon xx and epsilon yy, which you are writing here, it is the Poisson effect does come into play. Uh,
I asked about Poisson effect. Initially, I thought that we need to use the Poisson effect for finding epsilon yy from thermal expansion. But I remembered from the structural mechanics was that thermal expansion is there's no Poisson effect in thermal expansion.
yeah.
We just add deformation to all components all the time.
Yes. 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 Okay. So I think this is clear. So we just need to substitute the value. So 1 plus what's the Poisson's ratio? Yeah, it's 0.24. Alpha is 10 to the power uh, minus 5 per degree Celsius, and delta T is what? It raised to 600 from 30, so it's 570. So 570 10 power minus 5 into 570.
Sorry, this is one plus new comes from two equation in the bottom. Yes, I just I missed the connection. One plus new. Where's one plus new comes from?
Uh, it I haven't said like it's directly. If you see uh, uh, what do you call this thing?
Inverse of a Hooke's law.
Yeah. So if you better do this, because for plane stress and plane strain, this D thing is different for the two cases.
Okay, I need to consider plane stress and plane strain Hooke's law.
Yeah.
Invert this and establish this equation.
Yes.
Okay,
Yes.
thank you.
So
Sir, I'm from civil engineering background. So, is the plane stress and plane strain which I studied in the civil background same as applied to the thermal problem?
yes, I do think because I am also from civil background only. Uh,
So, in
eh,
plane stress, we say it's a two-dimensional body with in-plane loading, and we derive the equations accordingly, or we
uh,
modify the usual equation. And for plane strain, also usually long bodies like pipes, dams. So that is the concept I have. I don't know how to apply it to the thermal problem.
see, I think you are saying just the opposite thing. The long body things are for plane
Plane
strain.
strain,
Yeah,
strain. Yes,
yeah,
that's
plane
what I
strain.
meant.
No, no,
Ah,
actually, what you said was opposite. That's why.
oh, I see. So plane stresses for two-dimensional body, thin bodies.
Thin, yeah.
Yes, that's
Uh,
what I meant.
uh-huh.
Plane strain for long bodies.
Yes. So that is still applicable, but normally every body is a general body, but we do have special cases where we can ignore other effects. So we have solved for like plane stress and plane strain conditions, and accordingly the governing equations been modified so that our calculation become much more simpler. So if uh, what we normally solve for most of the time, epsilon xx, epsilon xy, epsilon yy. Why don't we solve for epsilon xz or epsilon zz? We focus only on these three aspects, right? So accordingly, our D, the constitutive matrix, is changed considering what we have, whether we have plane stress, plane strain, or whether it could be a cylindrical body as well, like
Axisymmetric.
axis symmetric, yeah, axis symmetric body. So I don't think.
Yeah, it's okay, sir. I got confused and simply asked. I just catch up.
Okay, so I hope some assistance has been provided regarding assignment number 9.
Sure,
Now,
sure, sir.
now we'll move
Perfect.
on to week 8, assignment 8 solutions.
Yes, yes.
If it's fine with Rafael as well as Abdullah, I'll move on to assignment 8 solution.
Can I ask last question about that?
Okay, yeah.
So we have a plane stress, a plane strain condition there, and we just have a general body, and we have this instantaneous rise of the temperature, right? Right.
Yes.
So we only have information about deformations, and we can calculate stresses also by the Hooke's law.
Because
Or
it's already
yes
been
or
provided that it's a plane strain condition. We don't need to see the actual body, right? Or how the uh, boundary conditions has been applied. We just need to
yeah,
know.
yeah,
Yeah.
yeah. It's interesting that I don't remember there's one plus mu there, and I'm interested in deriving that. Therefore, I'm asking questions.
Okay.
Okay, I try to solve it.
Yeah. Okay.
Thanks.
Yes. Yeah. So okay, we'll move on to assignment 8 solution. I'll write that. Okay, meanwhile, what I will do, because the notebooks are also shared in the drive, so as you're saying it's gap here, I'll upload the question number 5, 6, 7 as well. You better see this because in the subsequent uh, discussion sessions, I might discuss it here also. Okay, so likewise, question number 9 and 10. Now, we'll discuss assignment 8 solutions. Let's do this. Week 8, question 1. Okay. I expect everyone to answer quickly regarding week 8. So, yeah. Question number 11 or what? Question number 1 of assignment 8. So this was the question. Consider two-dimensional domain which is discretized with triangular elements as shown below. The domain is subjected to Qn at its boundary and the elements are shown inside the circle. Identify the incorrect option corresponding to the boundary integral to find Qe for the domain. Qe is the and options are for element 4 we need boundary integral, for element 2 we need boundary integral, option C. For element 3 we need boundary integral and option 4 we don't need boundary integral for element 6. So it's option C has been said. Okay, can anyone unmute and tell quickly why option C is the correct statement? Abdullah has been quite uh, a lot, so I would ask Abdullah, you can unmute and say something about this.
Yes, it's C also, like others, because the element number 3 is not having any side on the boundary condition or the applied flux Qn.
Yeah. What about element 2, 4, 5, 6, 1? 1, 2, 4, 5, 6. You can say everything about other elements. Abdullah.
Only 2 and 4 needs, others none doesn't.
Yeah, yeah, you're absolutely correct. So, if we see the element in question in consideration, so element 2 and 4 will only need boundary integral. 1, 3, 5, 6 all are inside, so they won't need the boundary integral. Okay, I hope it's clear for everyone. If anyone wants to jump in, you can. I'll second question. Okay, question 2. So question number 2. Consider a higher order triangular element which is subjected to a boundary flux to one of its sides. Nodes of the element are shown in red dot. The boundary flux vary according to the ninth order polynomial. What will be the order of the polynomial n so that it can be captured exactly? And the options are 1, 2, 3, and 4. Option D is none of this. So answers. Okay. Both Rafael and Jess has said option C. This time I'll ask Jess to give the answer or clarify, yeah, give more uh, info about this question. So, Jess, can you unmute yourself and say something about it?
Four nodes will pertain to cubic polynomial. There are four nodes at one side,
Yeah. Okay.
so cubic polynomial is needed.
Yes. So as you can see, for we have a uh, this is a Lagrangian element with 4 nodes per side. Uh, Triangular element, I would say, and 4 nodes per side, and per side we have 4 nodes. So for a polynomial to capture, like suppose we want a displacement value, so a naught plus a1, but I start with a1 plus a2x plus a3 x square plus a4 x cube. So the 4 nodes will give me these values, right? So fine, it will give me the exact values till the order degree 3, right? So uh, correct answer would be option C, cubic polynomial, right? What if this had been, the question would have been uh, 1, 2, 3, 4, 5, 6. Yeah. What if the question had been like 6-noded triangle? What would have been the answer pertaining to this? N equal to 1, n equal to 2, n equal to 3, n equal to 4, or none of this. Guesses? Am I audible? Okay, so Rafael said n equal to 2, Jis has also said n equal to 2. Yeah, so answer would be n equal to 2 only. Okay, so let's move on to the next question. Yeah, Rafael wants to add something.
I have an answer. I have an answer about question about this, and because it is the question asking capture exactly,
Yeah,
right?
yes, yes.
Well, why we cannot say that a linear and quadratic and cubic also can capture it exactly? Because
Uh,
for polynomial like linear cubic, it will be a1 is equal to something, a2 is equal to something, a3 is equal to 0,
yes,
for
yes, yes.
instance. Why
That
we
is
cannot say that?
that is a tricky question actually. Yes,
Yeah,
uh, you are correct in that aspect that if it is able to capture cubic, it will also capture quadratic, linear, or constant values as well. So, so in this regard, I would just say if it had been MCQ type, then option A, B, C, or what I was in that regard, option A, B would have been the correct answers. But since it is a kind of objective answer, so like single answer type, then most appropriate answer would be option C for the question asked and option B for the question which I asked. I hope that clarifies, Rafael.
Uh, I also considered initially like that, but my father thought my father thought so was my father thought well if we have a linear element, a linear Q here, linear flux,
Yeah, that will
and we
also be
try
captured. Yeah.
and we try to with four nodes at the boundary. We can capture it perfectly, like
Yes, yes,
right.
yes,
It will
yes,
be.
yes. Without doubt, that will catch.
I just I started to doubt that
Oh, oh,
by this question by some reason because I thought that we approximate, not interpolating there.
yes, yes, yes.
I believe that
I,
approximation will be not
uh,
exact.
I think by this time you must have understood there are a lot of trickiness in the questions asked. Like just one word can change the meaning. Like earlier we used to ask like what is the incorrect statement among all the statements, right? Kind of like that.
But we're doing interpolation and
Yes.
or approximation. I just started think if we approximate function with cubic polynomial, I believe it will be
No, it will give
not
an
exact.
exact value if see the approximation will work exactly for the polynomial in consideration which is giving exact values like we are in the same page when we are considering
Look,
n
look,
equal
look.
to
Oh,
3.
can I bring a detail to my question?
Yeah, sure.
One detail. I wanted to doubt this. If we have a, for instance, polynomial for, let's consider, let's please consider three nodes polynomial.
Okay.
You know a function for three nodes polynomial. Can you remember this nodal function when one is equal to one minus x, one minus. Can we remember this functions for three node polynomial?
So you're
I
saying uh, suppose this.
no shape functions. No. Three nodes polynomial in linear element. We consider boundary. We need to we need to
It's a three
three func.
noded triangle, right?
No. We consider boundary. So if we consider this projection of these functions to boundary, it will be usual three nodes polynomial functions.
Okay, so that will be like a1 plus a2
No,
and
no, no, no. N1 is equal to y minus 6.
I am not able to understand this.
Okay. Let me what, let me see. Let me see. Okay. Uh, in assignment 8, we do a task where we need to find a uh, boundary values, vector for boundary forces, and we used functions there. 1 minus 2s 2l. Can you write after me?
Okay, just a minute.
And
Yeah, yeah.
and 1 is equal to 1 minus 2s divided by l,
And 1 is equal to 1 minus
2s divided by l,
2s divided by L.
1 minus in the bracket 1 minus s divided by l.
1 minus S by L.
Yes. And 2 is equal to 1 s divided by l
Yeah.
multiplied by 1 minus 2s divided by l. And for the node 4, we have and 4 uh, 4 multiplied by s divided by l.
Node
For
3 and 3, right?
no, in the boundary we had a node number 4 because 3 was a number not on the triangle.
Okay. This is with regards to assignment only or lecture?
Yes, it is my question right at the moment. 4s divided by l, 4s divided by l
4s
multiplied by
divided
um, 1 minus s divided by l.
1 minus S divided by L.
Can you draw a triangle?
Please check whether I am correct or not.
Yes, I believe yes.
because
Can you draw a triangle, please? And draw a triangle, please, here.
you're saying like abrupt or the
Yes, a triangle. And you just draw a random triangle.
okay.
Okay, random triangle, and we have 1, 2, 3 nodes in the clockwise order.
1, 2, 4, right?
1, 2, 1, 1, 2, 3.
You
1,
said
2,
you said
well,
4
not
here.
1, 2, no, 1, 2, 3. And we also have points like intermediate points there. 1, 2, 3. 1, 2,
1,
3.
2, 3.
And in the center of each length, we have nodes, additional nodes, like where it is 1, 2, it is 4 node. 4, 4, 5, 6. Between 1 and 2, we have 4. Yes, this. And we have a flux on the side 1, 2.
1, 2. So
We have a flux here. We have a boundary. Yes, here it was a boundary term. Okay. In the question asks us if we
okay.
have a boundary about this of linear order, can we catch it exactly with these three functions?
Okay. Sorry to interrupt. Is
Yes.
this with regard to assignment question, right?
No, it is regards to my questions to the that we can what we discussed earlier. If we have a linear polynomial here, we
Okay.
can exactly catch with these three functions, yes
Yes.
or not?
Yes. Yes.
But because I started to doubt here because
No. No. No.
some
You can capture perfectly. There is no doubt about that.
Can I interrupt?
Yeah. Sure.
Yes, actually, what I'm understanding from Raphael's question is there is no relation between the order of the polynomial that govern the flux and the order of the polynomial that we are using for approximation, because the approximation depending on the number of nodes that are there on the side of the element. But the order of the polynomial or the flux may be higher. So when we're capturing, it's just an approximation. It's not an exact capturing, right?
Abdullah, thank you. But question asks that if we have some order of Q, we can capture it exactly with our nodes. This is a question, and
like
with
in
us,
the question it's like there is a relation between the order of the flux and the order
yes.
of the approximation polynomial, but as we know there is no relation, because the choosing of the polynomial order it depends on how many nodes we have, and since we have here we have 4 nodes, so it's cubic.
Okay, when we have if let's assume that our flux is order of 1 at this
Like
case,
if
and we have
like
4 nodes, can we catch it exactly?
Yes.
Yes,
yes,
answer is
but
yes.
if
Yes. With
but if
regards
our
to this
flux
question, yeah.
Yeah, but if our flux is like from the order of 7 and we have only 4 nodes, we are not able only to capture till cubic, but the 4, 5, 6, 7 we are not being able to capture.
So
I think as I understand.
We can capture it, but not exactly with
yes, that will
approximation.
be approximate value. Yes.
Exactly.
But now I started to doubt that we even cannot capture
No. No.
less
No. No.
order.
No. 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 Don't doubt about
So
that.
if I use this no shape function as we wrote and put numbers there, how I should approximate our Q here? I believe I don't understand. I don't understand what I should do to check if I'm catching it in exact way or not. What I should do?
See, how do you normally calculate Q or the distributed load
For
at the
instance,
node
it's linear.
and transpose QDS, right? If you remember it.
Yes. Thanks.
So,
I forgot that.
yeah, so this is it. Like Q1, Q2, Q3, whatever be.
Okay, thanks. I will check that. If we substitute some linear function, we need to capture it perfectly. I just want to substitute some linear function, and if this polynomial will work.
Yes, yes, you can cross check it. Yeah.
Okay, thanks. But when when this question was asked, I I I was perfectly sure that if we have less polynomial, it was exact. But there's no
The,
option to check to choose one and three linear polynomial and linear constant and polynomial cases. So I got serious doubt here
okay,
by
okay.
submitting.
No worries,
Sorry.
no worries. I think that has been sorted now. I suppose you don't have further doubts, is it?
Yeah, I will check.
Yeah.
At least I know how to check. Thanks.
No. Yeah. Okay. Think it's all almost 1.5 hour done. Let's see. Question 14, 15.
Could you uh, do you have another example of this? Because
Sorry,
do you have
I.
another just to practice? Because
Okay, so regarding which? This one.
no, the last problem you add to our quiz.
Yeah, yeah, this one, right? See in the screen.
No. Question 14. Like that you were busy about this problem, right?
Okay, this one.
This one. Do you have another example of these problems like to practice? Because this was solved
Okay,
by us in the
okay,
assignment,
okay. Let me check.
and the solution also provided.
Okay, let me check. Uh, this is with regards to. This is similar. No. Okay, so you can have this one. This question. This is with regards to temperature, right? Yeah. So please see this question.
Okay.
4 to 6. Okay, what I will do, I'll just post this question itself. You better deal this. Question for you guys can practice. Question 4 and question 4. These are the question pertaining to this. Question 5. Question 6. Okay. Okay, now let's solve this question. As Rafael, you have already got an example to practice this kind of question. So you better deal with this. In the next class, I will get with you get with you guys like what would be the correct answer pertaining to this question. Okay, 14, 15, 16. Now let's move on to this question.
Uh,
Yeah,
can I ask a question? Can we expect that geometry will change in the exam?
you be
Because I registered successfully in the exam, we have a payment problem between Russia and India, so it was difficult. But I finally registered to the exam, and now I wonder: can I expect that in the exam will be like more complex geometry?
I would say truthfully, I have no idea.
Okay. Because guys from MBTL like to do that. It's a little surprising thing.
No,
Change the geometry in exam.
no. So it's
Is
better be prepared in that aspect as well. Okay. So can we move on to the question now?
yes.
Yeah. So this is similar to what I discussed in the last session also. This is consider the following linear isoparametric mapping from a parent domain to a physical domain. What we were saying is master to slave or something like that. So location of the quadrilateral in physical domain is shown. Now answer the following question based on the following isoparametric mapping. With the help of isoparametric, so the question is question number 17. With the help of isoparametric mapping, x and y can be written in which of the following parametric form? So this is the question. I think you guys.
Yeah, I'm glad that you choose the complex transformation in such a way that our Jacobian will be dependent on zeta and eta. Sorry, psi and eta.
Yeah.
I believe we need to start with definition of x and y in terms of our nodal. We need to write down our functions, nodal functions for master element, and then we need to use the coordinate transformation x and y with respect to them.
Yes.
This is the first step, I believe.
Yes. So okay. So I think we are everyone on the same page regarding that. How do we start it? So first we need to find the shape function in terms of the natural coordinate system. So let's see. As you all know, what will be n1 in terms of xi and eta? Okay, I better draw this. 1, 2, 3, 4 in zeta coordinate system, and that is being transferred to this xy coordinate system. So n1 would be equal to 1 minus, I am not okay, that's right. Then n2 would be equal to 1 upon 4. This would be 1 plus xi 1 minus eta. Then n3 would be equal to 1 plus xi 1 plus eta 1 upon 4, and n4 would be equal to 1 minus xi 1 plus eta upon 4. Okay, now it's just simple thing. X is what? N I x I equal to 1 to 4, that is n1 x1 plus n2 x2 plus n3 x3 n4 x4. Right, and you just need to substitute it. So okay, so see this one, x1 is 2, x2 is 4, x3 is 4, and x4 is 1. Okay, uh, okay, n1 x1 is 2.
Can you show this again? This element, coordinates of the element. Can you show, please?
Yeah, 2 4 4 1.
Yes, thank you.
Yeah, okay, no problem. So this will be equal to now 1 upon 4 1 minus xi 1 minus eta times 2 plus 1 upon 4. Okay, so 1 upon 4, 1 plus xi 1 minus eta x2 is 4 and plus 1 upon 4, 1 plus xi 1 plus eta times 4 plus 1 upon 4, 1 minus xi 1 plus eta times 1. Let's simplify this. Then this will be equal to, okay, so I'll take 1 upon 4 outside. So this will be equal to, if I take 1 minus eta as common for this, 1 minus eta is common for first two, so it will be equal to 2 minus 2 xi, and this will be equal to 4 plus 4 xi, and 1 plus eta common, then 4 plus 4 xi and plus 1 minus xi. So this will be equal to 1 upon 4, 1 minus eta. This is equal to 4 to 6 plus 2 xi plus 1 plus eta. This is equal to 4, 5 and plus 3 xi. Let's simplify it further. 1 upon 4, this is x minus x eta, then 2 xi minus eta xi 2 eta xi plus 1 5 plus 3 xi minus 5 eta plus 3 eta xi. Now constants are 6 plus 5, 11. Eta is here and here, so that is minus eta. Then xi is 2 plus 3, 5 xi, and eta we have eta xi. So yeah, it's 1 by 4, right? So this is 8 for x. Similarly for y. Okay, so y equal to n1 y1 plus n2 y2 plus n3 y3 plus n4 y4. You have y1 equal to, okay, 1142 1142 1 1 4 2. So y2 equal to 1, y3 equal to 4, y4 equal to 2. So y equal to 1 upon 4, I'll take this out, 1 minus eta times 1 plus n2. Sorry, plus xi1 plus xi1 minus eta times 1 plus 1 plus xi 1 plus eta times 4 plus 1 minus xi 1 plus eta times 2 equal to similarly I'll proceed in this one. I'll take 1 minus eta as common, so this will be equal to 1 minus xi plus 1 plus xi plus 1 plus eta. I'll take common here for the other two. So this will be 4 plus 4 xi, and this will equal to 2 minus 2 xi equal to 1 by 4 1 minus eta times 2, and here we have 1 plus eta times 4 to 6 plus 2 xi. Okay, further simplification, 2 minus 2 eta 6 plus 6 eta 2 xi 2 eta xi equal to 1 by 4, and this is equal to the constants will give me 8 eta have 4 xi as 2 xi and 2 eta xi. If I take 2 as common, so it will become 1 by 2. This will be 4 2 eta xi eta xi y. Okay. Let's match it with the options. So 1 by 4 11, I can say 11 minus eta 5 xi plus xi eta. Yeah, so this matches with here this one. See this one, 1 by 2 4 plus xi 2 eta xi eta 4 2, yeah, this one is correct. Yes, so option C would be the answer. Rafael,
Yes.
yeah, you have written 1 minus d xi times 1 minus eta upon 4.
It was an answer to your question when
Okay,
you
okay,
asked about
okay.
Jacob.
Yeah, thanks. So I think nobody has doubt in this regard, in this solution.
No.
Can I get confirmation from others also? Jis, Abdullah? Which zoom in a bit. Okay, yeah. It's just complete substitution. Like first, you need to know what will be my step functions, and just substitute the values of the coordinates into this. Okay, now we'll move on to the next part of this question. So what will be the determinant of Jacobian J? And as you all know, the answer to the previous question would be applicable to here. Like we need to utilize that answer to solve this. Okay, I'll give you all time. Can you guys come up with the answer? So this is my x and this is my y. Are you guys trying or should I start?
I'm
Okay, I'll wait for a minute.
I try to solve this.
So you got the answer? Wow, what's your answer?
I just wrote the matrix. I
Okay, you have not actually solved. Okay, fine. So yeah, the Jacobian matrix would be with this regard would be what? Jacobian
dx
matrix.
d xi dy dxi and dx d eta and dy d eta.
Yeah, dx dot eta and y under eta, right? And we came up with the answer x is equal to 1 upon 4, just 11 minus eta, 11 minus eta, also write this way, 11 minus eta plus 5 xi plus xi eta, right? Yeah, and y as 1 by 2, 4 plus 2 eta xi and xi eta. Okay, with this in and we'll have dou x by dou xi is uh, 5 by 4 and eta by 4. Okay, dou y by dou xi would be equal to 1 by 2 plus eta by 2. Dou x by dou eta would be equal to minus 1 by 4 plus eta by 4, and dou y by dou eta would be equal to 2 by 2, that is 1, and dou y by dou eta, it will be equal to xi by 2. Okay, this is my Jacobian matrix. So the determinant of this is just multiply 5 by 4 plus eta by 4. Okay, like this, 5 plus eta, 2 plus xi times 2 minus 1 by 2, 1 plus eta xi minus 1 times 4. Okay, so I can take 1 by 8 outside, and this would be equal to 10 5 xi plus 2 eta xi minus 1 xi minus 1, and okay, so xi minus xi plus 1 minus 1 minus xi minus plus 1 and minus eta, that will give me minus eta xi and plus eta. It's eta plus eta, yes. So solve this, 1 by 8, this will be 10 plus 1 11, xi is equal to 4 xi, 2 eta, this will 3 eta, and the eta xi will get cancelled out, right? So this is the answer. 1 by 8 times 11 plus 4 xi plus 3 eta. 1 by 8 times 11 plus 4 xi plus 3 eta. Okay, so we have 1 upon 16. So we can transform here. If we write it 1 upon 16, we can write everything multiplied with 2, 22 plus 8 xi plus 6 eta. See, 1 by 16 here 8 xi plus 6 eta, right? Yeah, so answer would be option B. Okay. Okay.
Well,
Yeah.
sorry, what do you multiplied by 2?
Okay. See in the we got the answer as 1 upon 8 times 11 plus 4 xi plus 3 eta. So if you see in the options, there is no 1 upon 8, it's 1 upon 16.
Okay.
So okay, so I converted this into 1 upon 16, then I multiplied 2 on the numerator also. Okay, Let's solve today's last question. Let's say question 9. Okay. Uh, I won't directly ask the question solution actually or answer. I'll just ask how would you guys proceed. Suppose we have one integration in physical domain over the quadrilateral and we want to transfer the integration to the parent domain to carry out the numerical integration. What will be the form of the following integration in parent domain? And I think this is in continuation to the question 7, 8, 9. Yeah, so this is in continuation with the above question. So how would you proceed? Anyone can unmute and yeah, Rafael.
In order to answer this question, we need to know how many points do we have in integration. But there is no presented. This is just general formulation. What we should do, we need to substitute all values here in terms of x and y that we received already, and multiplied by Jacobian.
Yes, so the question asked is we need to find this integration, right?
Yes, we just substitute all
Yeah,
values that have received for x and y, and we just
you just need
we
to
do a transformation
yes, so
transformation variables in two-dimensional case.
you just need to substitute x and y values in terms of xi and eta
Oh, you are right.
and
Okay.
the xi, the eta, and this will be like eta minus y to 1 and xi minus y to 1. This is what needs to be done. Okay, to elaborate it further, what we got earlier is minus 1 to 1 minus 1 to 1. So x we got was 1 upon, I don't remember it. This one was it. Ah, okay, x is equal to 1 upon 4, 11 minus eta. 11 minus eta plus 5 xi plus eta xi. This one is x, y.
This is clear what we should do. Can we discuss one point here
Okay,
about
just
how we're choosing number of points in the integration?
okay. 1 minute.
If you have.
The Jacobian was 1 upon 16, 22 plus 8 xi 6 theta and integrated xi theta, and you guys can calculate this. Okay. Yeah, you were asking, Rafael.
What I'm trying to ask it is how we're choosing number of points in the integration in each direction in appropriate way.
Okay.
As I understood, there's some strategy here. Just sometimes we choose different points of integration for some problems.
Okay. Okay. I'll
For
just
instance, in that direction, we can use 1 point, and for this direction, we can use 3 points.
3 points. Yeah.
How choose How we choose this?
Okay, I'll give you a hint. You try to figure it out. Okay, so suppose we consider only one direction, x itself. Okay, uh, if we consider only one point, one integration point, it can integrate up to how what degree of polynomial? It can up to certain, right? For two, if we consider two integration points, it will give value up to uh, it's 3, or I think it's 3. Yeah. So if we consider two,
Okay, one point integration, one point of integration in Gauss gives us order of what? I forgot this actually.
see,
Sorry about that.
okay, I'll again say, what do we, how do we use the numerical integration or something? Mm,
I know how to use, but I
fx
forgot the order.
dx. Okay. Mm, so in the numerical integration, we just use w1 f wi fi. Okay. So if fx or our integration point is only one, okay, that is w1 f1. So this can give me an exact value if my fx is linear polynomial. Okay, if it is greater than this linear n equal to 1, greater than n equal to 1, then we won't, greater than 1, then we won't get an exact value, we'll get an approximate value using numerical integration. Similarly, if we consider our integration point as 2, like w1 f1 plus w2 f2, so this can give me an exact value to fx dx, this I, this will be equal to I exact when my fx is uh, 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 cubic polynomial at most. If it is greater than cubic polynomial, then we won't get an exact value, we'll get an approximate value. If it is less than this, then uh, we'll get an exact value. Correct me if I'm wrong, Abdullah. Okay, so uh, so uh, this is one thing you need to keep in mind. Now you're saying like how you're taking uh, one integration point in one side and three integration points in other direction. So you can see this question itself. See this question. If you see in the dependence of x, we have a linear thing. But if you see the dependence of y in this function, it's quadratic, right? So for this to solve, you need to take two integration points in the y direction to get an exact value. I'm saying to get an exact value, you need to take two integration point along the y direction and one integration point along the x direction. I hope that clarifies your doubt, Rafael.
Yeah, thank you. I just I don't know why I'm trying to Gauss integration. I took this special course, but I was lazy and um, not forget not look not look through this at clear at details because I forgot which number of point gives me what exactly example. I just
No,
forgot
no
this.
worries. You can just look it up again. At least you should know the concept why the numerical integration is into play.
Okay, I just need to try to look at it again carefully.
Okay.
Thanks.
I'll just end the session now. I'll just. Uh,
By the way, will you be free to consider codes that they give again
Okay.
in the next session, or sometimes I don't know.
As I have considered like assignment 8 and 9 in this session itself, in the further session, I would just be patching it up like whatever question I have left it, I'll try to deal with that, and again I'll discuss questions regarding to that week itself. So by default, I would be left out with 1 week. So in that week, we can discuss codes if that is helpful for you all. If that is okay with you all, like maybe in the last week of our discussion session. Is
Okay, thanks.
yeah. I don't. Is it urgent? Like you got to solve the code now itself. Is it that urgent?
No, I just wanted if you have time
Clarification. Yes.
to yes, because some concepts is not clear, but I'm planning to do some
Yeah,
codes
yeah. We'll sit.
for my work.
Yeah, we'll sit one time and deal with that also.
Because TAs on the forum is not quite helpful this time. I don't know why. Okay, thanks.
I hope I am assisting in some way.
Yes, you insisting great because we have a productive interactive sessions.
Okay, thanks for the compliment. Okay, we'll end the session here now. Abdullah, if it's fine with you also.
Okay, thank you for the session. Have a
Yeah,
nice day.
yeah. Have a nice weekend to you
Have a
all
nice
as
day
well.
and Ramadan Mubarak.
Uh, आप सबको भी रमजान मुबारक. Bye. Take care. Have a nice weekend. We'll meet on the next weekend. Bye.